Welcome to this implementation demo where we're going to show how the Mifos PHE implementation of Payments Building Block all the way through to end DFSP entities has been implemented and show some transactions flowing through this to prove the technology. We will start by giving an overview of the demo environment we have built, and then we're going to walk through each of the 5 scenarios that demonstrate how end-to-end transactions flow through the platform. So firstly, let us look at the demo environment. You'll see this has been split up into 4 sections. One section covers the government functionality, effectively the Govstack implementation of the payments building block using Mifos PHE. The second section is the payer infrastructure we've built out, again using PHE but using Fineract as a DFSP instance, replicating a central bank where the program accounts would be held. We have switch infrastructure in the middle using Mojaloop. We also have a mock stub we use for Mojaloop as well in one of the tests. And then we have the payee infrastructure section. We've got 3 payee DFSPs, one acting as a mobile provider and 2 others acting as bank accounts. So in this first scenario, we're going to show bulk transactions split by payer DFSP. So we have one payer account set up with Organda tenant and 3 different tenants set up for the pay DFSPs, as we showed in the diagram, with an account in each of those. And we're going to push through 6 transactions in total and see how it works.
In this demo, we are going to demonstrate capability of bulk processors batch transaction API, which is capable of processing a transaction file containing multiple transactions may or may not belong to same paid DFSP. We will also demonstrate its splitting feature, which you can configure according to your need, or also you can enable to split based on paid DFSP for certain tenant. We will start by first understanding the batch transactions API. So yeah, as you can see, this batch transactions API takes tenant in header. Right now we have configured tenant as a Rhino. In body, it expects a CSV file. So this file have multiple transactions, and if enable, those multiple transactions can be further divided into sub batches. You will receive a response like this, and a callback would contain a batch ID and a message indicating the percentage of transaction which has been processed after 2 minutes. Okay, so we will demonstrate its feature through certain different feature files. We will start by first demonstrating how splitting based on account lookup and number of transactions work with tenant as a Rhino and having a number of transactions 6. Let me start this. Okay, meanwhile let me show you the payments file. As you can see, there are 6 transactions, each having different request ID. These request ID will further be used as transaction ID, so make sure they should be unique. Here payment mode is closed loop, and we have a pair identifier type as account number. And in pay identifier, you can see we have basically 3 different types of pay identifier, one payer and 3 different pay. So, and for this particular tenant, which is Rhino, we have configured splitting to be based on pay. Okay, let me also show you the configuration which we have done in application.yaml. As you can see, payment BB1 is configured with Rhino, payment BB2 is configured with Gorilla, payer FSP with Wakanda, and we have three different pay FSP 1, 2, 3, Pluto, Venus, Jupiter. Okay, so this test was successful. Here we are using this file and making a transaction to this batch transactions API. Here I have already shown you that batch transactions API expects a CSV file. Then we wait for the result and expect a status of 202. Further, in order to be sure that all the transactions have been successful, we call a batch summary API. So this batch summary calculates the aggregation of all the transactions and expects that total successful transaction and total initial transaction are same, and total successful transaction amount and initial transaction amount is same. Moving on, we also compare that each transaction is status is completed. Okay, let me also show you the database entry. So as you can see, this is Rhino. Let me refresh it. Let me retry it. Okay, it's connected. As you can see, although there were 6 transactions, if it would have been splitted based on number of transactions, which we have configured to be 5, then there would have been 2 sub batches. But here there are 3 sub batches, and this is the parent batch. You can see that according to pay, there are 3 files have been formed, and each pay had 2 transactions, so 2 to 2, and total of 6 transactions. And you can always see the result file from here. It has a link, and let me also show you. Yeah, so as you can see, in the parent batch, the aggregation total amount is there, and payer FSV, and in the response which we have got here in the batch summary response against this batch ID, we have a total of 6 transactions, successful 6 transactions, total amount 3524, successful amount 3524. Let me also show you the from the web UI. So this is Payment Hub. This was the last batch which we have processed, 3524, and timing is 9:69. And yeah, these are the 3 sub batches which were formed: 1600, 1580, 344. And let me check the transactions also. So as you can see, these are batch reference number and the amount, and show you the, yeah, as you can see, this amount and this request ID is same.
Thank you. So now what we'll show is those 6 transactions have gone all the way through the end-to-end environment we've set up, and we can do that by viewing the user interfaces for each of those end DFSPs. So if we log in to the Wakanda, we can see the originating account. So if we look, we can see the Govstack program account here with the external ID that matches the account that we've just seen. So if we look at the balance of that account, we can see the transactions that occurred. So we can see it started off with $100,000, then the transaction for $850, $222, $840, $750, $122, and $740 went out of the account, leaving an end balance of $96,476. Equally, if we then log into the Pluto tenant. We can see the account 4001731101996 that we were making transactions into. And again, if we look at the savings account there, we can see two transactions, the 850 and the 750 having gone in, leaving then balance of $1,600. We could equally look at the Venus instance. And again, if we look at the demo account here, that corresponds to the one that we just made transactions into, we can see the two transactions of $222 and $122 going in. So in this second scenario, what we're going to show is bulk transactions, this time split by volume. So the 8 transactions will be split into 2 batches. And we're also going to show transactions both by closed loop and via the Mojaloop stub.
Moving on, let me show you the second feature file. So in this feature file, we are having a different combination of payment mode with a second tenant, which is Gorilla. And we have here closed loop and Mojaloop together. Let me run this scenario. Yeah, so let me open this file where we will have a better idea. See, here there are 8 transactions, and first 5 are closed loop, rest 3 are Mojaloop. Then again we are using this file, making a batch transaction call to the batch transactions API. Remember, this is a different tenant, it's not the same which Rhino. So it should splitting should based on number of transactions, not according to the different pay FSP ID. Because since we have configured only Rhino, in the case of Rhino to be splitted based on pay DFSP ID. So it is successful. Total successful transaction matched with the initial number of transaction. Let me show you the batch summary response. Yeah, as we can see, there were initially total 8 transactions, successful 8, total amount 3066, successful amount 3066. And one interesting thing would be to go to the Gorilla DB and let me refresh it. Okay, it's refreshed. So as you can see, there are only 2 sub batches formed, right? It should be like yeah, total 8 and their total transaction 3 and 5, and 3 was for Mojaloop and 5 was for closed loop.
Thank you. So in this third scenario, what we're going to show is again transaction split by volume, but this time we're going to show the GSMA connector and transactions flowing accordingly.
Yeah, moving on to the third scenario. So here we are registering pair with pair FSP2 as tenant and pay with all these 3 different pay as tenant. Then we are generating this file batch transaction GCMA closed loop. Let me show you. See, there are only 7 right now, should be in the end 8. Yeah, so we generated this CSV file during runtime. We have 5 initial transaction as closed loop and then 3 GCMA. These 8 transactions get split into 2 batches, one with closed loop as payment mode and another with GCMA as payment mode. And here we have tenant as Wakanda for batch transaction, as I have already shown in the application YAML, the configuration we had. So again, after calling batch summary API, we got 8 successful transactions and all the status of all the transactions were completed.
Thank you. So in this fourth scenario, what we're again going to see is transactions split by volume, but this time we're actually going to see the actual Mojaloop connector and see the transactions flowing into a real Mojaloop Switch instance.
Moving on to the fourth scenario. Yeah, so here we are generating this batch transaction Mojaloop fund transfer file. First, we have started by registering different payer and PayFSP in their respective tenant. Fund transfer, yeah. So as we can see, there are only 7 right now. Let me refresh it. Yeah, so now total 8 transactions. First 5 are closed loop, whereas 3 are Mojaloop. So in earlier we used a mock Mojaloop endpoint, but here we are demonstrating that we are calling actual Mojaloop APIs deployed in our SIT, and as we can see, it called the batch summary API, and it should have got successful. Okay, it's completed. So it got 8 transactions as successful. Total amount was 36 and successful amount is 36, so it passed, and status of all transactions was completed only. This is
Thank you. So in our final example, this is the most complex one we're going to show, and it's more representative of a real world example where we'll push through many more transactions, and this time you'll see all the transaction types occurring: closed loop, GSMA and Mojaloop, and see those transactions settling in real time.
This is our final scenario. Let me run it first. Yeah. So in this scenario, we are using closed loop, Mojaloop, and GCMA in a single batch, having different payer FSP, different pay FSP, and having a third tenant as Wakanda for making the batch transaction call. Let me show you this file. So currently it has 8 transactions. Now it has 13 transactions. First 5 are closed loop, next 5 are GCMA, and rest 3 are Mojaloop. It will create 3 different batch. And then it is using this file to call the batch transactions API. Then we will compare that whether these 13 transactions are completed or not, and whether total successful amount is equal to the initial successful amount. Yeah, so it's completed anyway. It is showing that total there were 13 transactions, and successful transactions are also 13, and there are no ongoing or failed transactions.
Thank you. So now what we'll do is look at the Jupyter DFSP, which is where the payee accounts are, and we'll see that the transactions have flown through correctly to the right accounts. It's worth noting that 2 of the transactions were actually targeted to one single account, and we'll look at that and make sure they've both gone into it. So for our more complex example, if we go in and look at Jupyter, we can see we have the clients within here with all the accounts that were created. So for example, if we look at the first account, which had $10 credited in, so that's 3779, that's an account with John Smith. We can go into his savings product and we can see he received $10 on the 17th of May. Equally, if we go back out and look at 3789, that was Joanne Summers, that was the one which had 2 Mojaloop transactions. We can see the 2 transactions of $3 and $2, giving a total balance of $5 gone in. And we could look at any of the other accounts and equally see the respective amounts have been credited into their accounts. Thank you. So what we've demonstrated in this video is an end-to-end infrastructure can be set up using the Mifos implementation of the payments building block for Govstack, and end-to-end transactions can flow all the way through the Govstack systems, orchestrating payments through the central bank for the program accounts through to end-to-end DFSPs receiving the money in the payee accounts. Thank you for watching.